Hello everyone, let's take a look at our next problem. Suppose that x, y, and z are three positive numbers that satisfy the equations x, y, z equals 1, x plus 1 over z equals 5, y plus 1 over x equals 29. Then z plus 1 over y is equal to m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so my first thought is we're given a system of three equations with three variables. Those are the first three equations. And so, under nice circumstances, there's a unique solution for x, y, and z. And then we can just compute the value of z plus 1 over y. It's possible that maybe we won't be able to easily solve for all three x, y, and z, but maybe we'll be able to manipulate the equations so that we can directly compute what z plus 1 over y is. So I think what I'm going to do is just start with the three original equations and manipulate them in some ways, and hopefully come out with what the answer is. I don't really have an idea of the best direction to start in, but I'm just going to start playing around and manipulating these equations and see what happens. Okay, so the straightforward approach of just trying to solve for all three of these variables is what I ended up doing. I did initially try very briefly to manipulate the equations in a way that would, I would come out with z plus 1 over y is equal to something, but I wasn't really getting there, or at least I didn't see a quick way to sort of end up where I wanted. So I just went ahead and solved for each of x, y, and z. There was one particular point when I noticed that I had equations that had both y and yz appearing linearly. So I treated y and yz as separate variables, and I ended up with two equations in two variables, where one variable was y and the other was y times z. And then I just went ahead and solved for y by eliminating y times z here. So that was probably the only part of the solution here that was particularly interesting. I end up with m over n is equal to 1 over 4, so m plus n is equal to 5. That's my answer, pretty confident in it. But if I find any kind of errors, I think arithmetic mistakes are the only errors that I could have made here. Or if I have other comments, I'll put them in the description. Thanks for watching.